All right, now I'm going to teach you guys how to do a parallel circuit problem. Now guys, you're going to have to be careful when I give you a circuit because you're going to have to be able to identify, is it a parallel circuit or is it a combination circuit? Is it a parallel circuit or is it a series circuit or is it a combination circuit later on? We're going to do common circuits tomorrow. But in this case, I know it's a parallel circuit. Why is it a parallel circuit? Because there's more than one path for the current to go around. So it is a parallel circuit. So then I have to be thinking, okay, I'm going to use the parallel circuit rules. Parallel circuit rules, let's see, let me think back to my auditorium example. So that means if we add resistors, it's easier to get out, so less resistance and more current. Okay, yeah, okay, I got it. All right, so if we think back to that, there's one thing I need to figure out. Well, where do I put the 5 volts in? Well, that's the voltage for my battery. So I'm going to put that in here for 5 volts right there. And then it's like, well, what could I do now? Well, we could do a couple different things. If you wanted to, you know that in a parallel circuit, that the voltage is always the same. Remember, voltage is across. So if I have 5 volts across here, I have to have 5 across there, 5 across there, 5 across there. So I could plug in 5 volts, 5 volts, and 5 volts. Okay? Then if I wanted to, I could use my Vernas equation. So if I say 5 divided by 5, I get 1 amp. If I say 5 divided by 10, I get 0.5 amps. If I go 5 divided by 15, that's 1/3, so 0.33 amps. And then now to find my totals here, I could do this a couple different ways. Now, and you should know how to do both, because sometimes you might have to do either. One way you could do this is, I know that in a parallel circuit, the total current adds up. Because if I have 1 amp here, 0.5 there, 0.33 there, I have to add that up. So it would be 1.83 amps total. Okay, now to find my total resistance, I can do this a couple different ways. Guys, you got to be careful here, though, that I know my total resistance. I can't just add them, because you add them for a series circuit. This is not a series circuit. This is a parallel circuit. So to find my total, I could either say this divided by this to get this, or I could add them up, so add the inverses. So I could say, okay, well, 1 over my total, so I'll say 1 over RT equals 1 over 5 plus 1 over 10 plus 1 over 15. Okay, now I've seen how you guys do on with equations or with fractions there. So let's just get your calculators out. So everybody get your calculator out, and we're gonna punch this in. So get your calculator out. Get your calculator out. You know. So if I do this, I get. All right. So I get 1 over my RT. 1 over RT equals 0.367. Now here's where you guys have to be careful. I don't want to know 1 over RT, I want to know RT. So what do we have to do? Well, we have to take the inverse of this. So if I take the inverse of this, so inverse, and I get 2.72 or 2.73. So my total is 2.73 ohms. Okay, so 2.73 ohms. Well, what's the other way that you could check this? Well, I could say, use my Vernas equation and say 5 divided by this. Do I get 2.73? So let's say 5 divided by 1.83. And sweet, I get 2.73. So it works. The nice thing about circuits is you can always go back and check. Well, how am I going to figure out my power column? Well, power, remember, always adds up. But first, if I take I times V, I get 5 watts. And then I get 2.5 watts. And then I get 1.67 watts. 1.67 watts. And then this times this, 1.83 times 5, I get 9.115 watts. Now if I add these three together, 5 plus 2.5 plus 1.67, I get essentially the same thing. We're a little bit of rounding error, but same thing. So I can always check, and make sure it works. Parallel circuits, man, what fun. I bet you can't wait to do your homework. Bye, kids.